Today's heat pump systems often consume more energy than expected. And the challenge for that is that the heat pump systems are not performing to their full potential. Their energy consumption is higher than expected, which is really not giving us the return on investment that we need. And the main reason for this is the secondary side of the system has a lot of dynamic factors. So it's not just the heat pump itself, it's how the heat is being used in the building. The big cause for this is pressure and flow changes that deviate from the original system design. The solution for that is having a dynamic hydronic balancing. And what that does is it stabilizes pressure and flow deviations to improve the efficiency of the entire heat pump system, essentially increase the envelope of design conditions that the heat pump can operate in. And what that also does is it's going to improve our reliability. It's going to extend the heat pump system's lifespan and optimizing the flow. Hydronic balancing, we found, is essentially required for complete system efficiency. It is the key to establishing proper indoor comfort while maintaining energy efficiency system operation in all climates and the entire year. Dynamic hydronic balancing valves address the root cause of unanticipated pressure fluctuations that cause the system imbalances and uneven water distribution. So stabilizing the pressure and flow conditions with hydronic balancing sort of works very similar to this. So like you have a garden hose. If you take a garden hose when you were a kid and you stretched it out and you turned it on, and water is going to flow at a set rate and a set pressure. When we don't have any balancing, as pressure changes in the house, someone flushed the toilet, runs the washing machine, that flow goes up and down. Or if you were to put your thumb on it and you were to increase the pressure is going to increase and it's going to go farther, but you're going to send less water. So when we look at a full load condition, which is typically how we've designed our static hydronic balancing, that's the single condition that our balancing is going to work at. And dynamic balancing is going to do the same thing that the static balancing is going to do in the same condition. It's going to work in the same way. Where dynamic balancing has a tremendous difference is when there's a partial load. And then it's essentially what a pressure independent control valve does is manage the flow and pressure as if your thumb weren't there, and the requirements for water can vary across a wide number of conditions.